Okay. So because I don't want to memorize a whole bunch of stuff, I think you're best off solving these by drawing a picture and trying to make the picture somewhat accurate. Okay, and the way that I would draw the picture, if you were giving me information like this, I would start with the angle. So 55 might look a little bit like this. I can always mess with the two sides here. So if that's 55 and that's A, then side A has to be across from it, right? Okay, so that means that if I call this side A, then that could be B. So let's make this B. Let's make that 25. And then I know that 23 would be a little less than that, so I'll make it come down like this. So that would be 23. So that's A is 23. So you sort of puzzle it together, and then erase this little thing over here, which unfortunately I can only erase the whole thing. So I erase the whole line, and then I'll redraw it so that I have a good triangle. So this is a triangle that might work with that situation. So angle B is also positioned then, and then this would clearly be angle C, and this is side C. Okay. What can I go find and how can I do it? I can find B. I can find the angle at B, right? What do I have to use for that? Right? And I have to use which combination? A over A, right? Because it's the only one where I know both. And then it's B over the sine of B. So if you were to cross multiply, it would look like this. So that means that the sine of B can be found by dividing that out. I need to backtrack for a second. If somebody can find it for me. So the sine of B could be 0.89. I did 25 times the sine of 55 and divided by 23. Then how do you find B if this is known?
Inverse.
Inverse sine. Good. Inverse sine of B. That's going to give me an angle. And unfortunately it's not a whole number, so 62.9. Okay, so now I have both angle A and angle B. So what's easiest to find next? Angle C. How do you find it? Right, 180 minus whatever those first two, which are A and B in this case, 62.9 and 55, what they add up to. And if you do that, then C would be 62.1. So everybody okay with how I found C? Okay, well once you have angle C, you can find the side at C, right? So I would still use A. So again, I'm going to use the 23 over the sine of 55. And then that will be equal to side C over the sine of 62.1. And we've practiced this a bunch already, so I'm just going to tell you that the answer in this case would be C is 24.8. Okay, and I know it was a little fast, but this is basically what we did yesterday, right? Not a whole lot different. Okay. Is this the only triangle possible?
No.
Why not?
Because the only angle that's set is the 55.
Right? And if you take the 23 and you rotate it,
You can have,
it would cut before A, right?
yeah.
So there is another triangle probably possible. So there is a second triangle possible, I think. How do you find it? It has something to do with this step over here. On your last test, when I gave you like the sine is something and you had to find the angle, how many answers were possible?
One,
No.
two.
2. Right? 2. If this was on the test, if I said the sine of an angle is 0.89 and you got that 62.9, then we would have been here in quadrant number 1, right? Where else is the sine positive?
The second.
Second, with this being 62.9. So what's the other angle? How do you find it?
180 minus.
Right, and that's what you need to do here. B could have been, because the calculator doesn't know which one it is. It could have been 180 minus the 62.9 that the calculator told us it was. Because it could have been in quadrant 1, but we could have been in quadrant 2. So that would have implied that B would have been 117.1 degrees. So now you have to do the same thing with a new value for B. So the next step was what? After you find B, you can find C. So you do 180 minus, keep in mind now it's 117.1, 55 doesn't change. So another possible measurement for angle C would have been 7.9. And if you use the 7.9, hopefully you understand you're going to also get a different value for the side length. So you do A over sine A is little c over the sine of 7.9, and so the second value for C that is possible is 3.9. When you're asked a problem like this, you have to give both triangles. It's not going to say, hey, find both. Okay, you're expected to understand that this might have two answers, and then you go look for them. Does anybody have questions on this and sort of the additional triangle that we came up with? Alright, I'm going to go do it again. So what if I have an angle of 44 and then A is 10.7 and C is 7.2? So I would start the same way with a triangle, with an angle AF around 44. So 44 might look a little like this. Okay, keep in mind I can always change the length here a little bit. So if C is 7.2, so I'm going to put angle C over here, so then I'm going to make this 7.2. I also wanted you to understand that it doesn't matter if it's called A, B, or C. And then A must be 10.7. So 10.7 is definitely bigger than 7.2, right? So I'm actually exaggerating that a little bit. I'm going to make that to 10.7 so that it's clearly longer. So that means I have to extend this a little bit. So I'm going to put C in the right spot. So I don't want it there. I'm just going to move it over so it looks right. Okay. So now B is over here in the top. How many triangles are possible now?
Only one.
Why only one?
Because 10.7 is the longest side.
Yeah, because now when you rotate, because you can't rotate the 7.2 because it's fixed because of the angle here. If you rotate 10.7, 10.7 coming from B would be somewhere over here, wouldn't it? Past A. You're never going to get another intersection on AC. So you can already see that we probably should only have one triangle, okay? This should only give me one triangle. The whole rotating part? Well, are you okay with the construction of the triangle? How it looks appropriate?
Yeah.
Alright. Well, keep in mind that the 44 is fixed, right? So you cannot move, like I cannot make C rotate. I can't pick up C and say rotate this way to the right. That's impossible because that would be changing the angle here. But you can rotate side BC. So if you take this side and rotate it, I'm just trying to see, will it ever cross between A and C again? Well, you know it can't, because if from here to here is 7.2, then 10.7 would be past that, right? Yes?
Yeah.
Well, that means I didn't cross AC before on the right side. The only time it will ever cross is over here on this side, but then I don't have the triangle anymore that I had anyway. So it's just based sort of on rotations of sides. So this problem should be a lot faster to answer, because after that, it's just the same thing. We only have one law of sines. So pick the pair that you have. We have side C, so use the 7.2 to find the sine of angle C. If you do this, the sine of C would have been 0.47. Take the inverse sine of that, and then that should be 27.9. Once you have C, I forgot to write that this is C. Once you have C, what angle can you find then? By doing the whole 180 minus stuff again, right? So now we have 27.9 and 44 as our two known angles. When you subtract that, B will be 108.1. And you finish the problem by using the 10.7 over sine 44. And then you say, that'll be alright. Thank you though. That would be side B divided by the sine of 108.1. Solve that for B, and you should get 14.6. Okay. If you don't feel comfortable with this whole rotation thing, then you can do the following, and I guess I'll do this one in blue then, is you can take a look at this and see what happens. So what you do have to remember is that if you think there's a second triangle possible, it comes from this. So you could say C could be, and then it would be, well, not the 27.9, it would be the 180 minus the 27.9. That would be the only other one that would be possible. Are we okay with that? If you do that, you get 152.1. So I'm basically repeating what I did on the first problem. Now go find angle B. Well, angle B has to be 180 minus, and the first angle is the 152.1. Well, that's not the first, that's the one we calculated. And then the given angle is 44. Which is more than 180, which clearly tells you that this wasn't possible, right? That's 196.1. So that's a good check. If you're not comfortable with the whole rotation, just do this. It takes what, 30 seconds, and then you know that, oh yeah, I did look at this correctly. It wasn't possible. So that's fine if you want that. So there's another way to confirm if you have another triangle or not. Okay? Okay, then the last one, and this is particularly for those of you that don't like drawing and stuff. So you sort of get used to doing all this, and you see, oh, okay, well that's just A, so it's 8.9 over the sine of A, sine of 55. And then I can just do B, which is given to us, 25.1 divided by the sine of B. You solve this for the sine of B, and you get 2.3. Then you take the inverse sine of this, and the calculator tells error. Well, what does that mean? It's not going to be a triangle. And you could have not done all this work if you had just drawn the angle at 55. Sorry, let me redraw that. That's not close enough to 55 for my comfort. Draw the angle at 55. So there's 55 degrees. If that's A, then A has to be over here. I'm going to put B somewhere over here, and then this is 25.1. And then you want A to be 8.9. There's 8.9 relative to 25.1. How are you ever going to get a triangle? You can't rotate AB up to meet it, because that would mess with this angle. This is not possible. Okay? Not possible. And the picture would have done that, or told you that right away. Okay. I do want to at least tell you this, because we did talk about this. If you take the sine of an angle, what's the largest value you can get, and what is the smallest value you can get? The sine will always be between negative 1 and 1. Because keep in mind that the sine of an angle represents what? Opposite over hypotenuse in a right triangle. And if that sine ever came out to be 2.3, how is that possible? How can the opposite side be bigger than the hypotenuse? It's impossible, right? This is another good reason why this doesn't work. Okay.